Welcome to the Accellerator.
We have engineered a brand new roller coaster that will blow your minds.
We have made many calculations to make sure this ride is safe. The first thing we calculated was potential energy. We calculated it at many parts of the coaster.
We first calculated from the beginning of the ride until the beginning of the loop. The potential energy here is the greatest because it starts off not moving and then it gradually speeds up.
The potential energy here is 2.041 joules. Next, we calculated from the bottom of the loop to the middle of the loop. The potential energy at this point is 0. The potential energy has now shifted into kinetic energy, the energy of motion.
Next, we calculated from the middle of the loop to the top of the loop. We only calculated one loop because both loops are the same size. The potential energy here is 0.5 joules because the height is 1 foot and the weight is 0.5 pounds.
Now on to the turn. After the loop, the speed lessens, but it doesn't slow down enough to stop the marble before the turn. At this point, the potential energy is 1.15 joules.
After the turn comes the jump. The potential energy here is 1.375 joules.
As we mentioned earlier, the top of the roller coaster has the most potential energy and the bottom of the loops has the least.
Now on to kinetic energy, which is energy in motion. For the top, the kinetic energy is 0 joules because it isn't moving. For the bottom to the middle of the loops, the kinetic energy is 246.45 joules, but it isn't quick enough to be the section with the highest kinetic energy. That award goes from the top to the bottom of the loop. The turn is 49.612 joules, and the jump is 9.8 joules.
We also calculated how long it took the marble to go through the entire track for maximum fun. The time it took was 3.98 seconds. We also calculated the length of the track in meters, which is 6 meters. Another thing we calculated was the average velocity for the track, which is 5.619 meters per second squared. And lastly, we found the acceleration for one loop, which is 1.167 meters per second squared.
We were looking for the positive acceleration, and we found that it speeds up at the beginning to the base of the loop when it is going down and when it is going down the loop. When we looked at the negative acceleration, we found that it slows down going up the loop, the turn, and the jump.
3 forces that could have slowed down the marble is friction between the marble and the track, air resistance, and lastly the funnel slows the marble down to a complete stop.
The gravitational potential energy at the beginning is the same as we mentioned before. It is 2.041 joules. We were looking for the force at one point in the roller coaster, and we found the force at the turn, which is 2.576 newtons.
Newton's first law is an object in motion remains motionless acted upon by an outside force, and an object at rest stays at rest unless acted upon by an outside force. This is relevant to our roller coaster because when the marble is on the turn, the track slows it down.
Newton's second law is force equals mass times acceleration. This is relevant to our project because if we don't calculate force, then there might be too much and the people won't be safe.
Newton's third and final law is that every action has an equal and opposite reaction. For our loops, we took in mind Newton's third law because we knew that if the loops weren't placed right, then the marble would fall off and everyone would die. The marble pushes on the track and the track pushes against the marble, making the marble stay on.
Thank you so much for watching our video, and we hope you pick up the Accellerator as your new and safe roller coaster for Six Flags.
Oh. Oh.